Good morning, everyone. I'm Julia Astashkina, Head of Marketing at Delta Stream. Welcome to the very first Watch It Work Thursdays. This is our new monthly live demo series where we cut through the noise and show you how real-time data works in practice. Today, super excited about kicking things off with FinTech use case that proves you can move beyond batch, cut costs, and simplify with SQL. And I'm thrilled to introduce you to Rachel Pedrewski, our head of field engineering. And with that, take it away, Rachel.
Thanks, Julia. Hi, everyone, and thanks for joining today. I've got a short, focused session planned. I'm going to show you how Delta Stream makes it simple to go from batch to streaming without the usual headaches. So we're going to walk through how we can build real-time pipelines, run fraud detection logic, and then visualize a live data and dashboard, all using SQL. So if you think of any questions along the way, so please drop them in the chat. Julia and I will keep an eye on them, and we'll go through as many as we can at the end of the demo. So please let me know if there's any audio visual problems. We'll try to sort it out. Okay. So first, just a really quick introduction of who Delta Stream is and what we're trying to solve. We help organizations unlock real-time intelligence from their data by unifying streaming, real-time, and batch workloads into a single SQL-first platform. Our company was founded by Hojat Jarafor. He is the creator of KSQL DB from Confluent. And we've been helping teams make stream processing approachable for a really long time. Our engineers and go-to-market team come from Red Hat OpenShift, Imply, and GridGain. I mean, all of us have spent many years building distributed systems at scale. And we're backed by NEA, Sanibel, and Galaxy, investors who see real-time analytics as the next big shift in data architecture. So this is one of Hojat's favorite lines. He starts all of our company meetings this way, and it really captures, why we built Delta Stream. Batch shows you what already happened. It's history. But streaming lets you act while something is happening, whether that's a transaction, a login, or a sensor alert. So our goal is to make streaming feel as simple and as stable as a database. And so let's go see how that looks. In the real world, especially in FinTech, everything happens real time. Transaction feeds, payment events, customer behavior signals. But a lot of data and analytics teams still process that data in slow, scheduled batches. That means by the time you spot fraud or a system failure, it's already too late. If you want to implement AI features, they won't have the benefit of up-to-date information. With Delta Stream, you can continuously process those same streams, detect anomalies as they occur, and push the results instantly to Snowflake, Iceberg, feature stores, Grafana dashboards, Databricks. You move from reacting to responding immediately. So I just want to pause here and ask, and welcome to put your answers in the chat. Would love to learn more about where you guys see yourself today. But where is your organization? Are you a level 1? You might have Kafka, or you might have some relational databases like Postgres that have CDC running, but you're pretty much still using batch jobs for analytics. Or you're a level 2, you've added something like Spark in places. It's faster, but it's fragile. Level 3, you've got a few real-time use cases on the infrastructure side of the house, maybe fraud detection or alerting, but it's custom code and hard to maintain. Or you're level 4 and everything is streaming first, governed, secure, reliable. And if you are, love to hear from you and let us know how you got there. But in reality, most teams get stuck somewhere between levels 2 and 3. They know real-time is valuable, but building and operating stream processing pipelines is expensive and requires niche expertise. Delta Stream helps teams move up this ladder using simple SQL without having to rebuild their stack or invest in costly infrastructure projects. Because even companies that already have Kafka often stop short of actually using it for real stream processing. And why? Because doing anything meaningful, joins or aggregations or enrichments to those topics means running Flink jobs. And that comes with baggage. You have to manage state, tune resources, wire up monitoring and scaling. It adds up fast in both time and cost. Delta Stream exists to make all of that simple and affordable. We handle the pipelines, the compute, the scaling for you, either remotely or in a bring your own cloud model. Either remotely in a bring your own cloud model or in our fully managed serverless environment. Both options come with enterprise grade security, full Prometheus based observability, and job level workload isolation. You get all the benefits of streaming analytics without having to stand up a Flink cluster, or hire a specialized ops team. Now here's how everything fits together. At the core, Delta Stream runs on Apache Flink. That's our engine for continuous stateful stream processing. For storage, Delta Stream separates compute from storage completely. You can keep your data where it already lives, in S3, Iceberg, Databricks, Snowflake, or even Kafka if that's your jam. Delta Stream just connects, computes, and continuously updates the outputs. When you do need to materialize data, you can store it right here in the platform, either backed by ClickHouse for high performance analytics or Postgres for lightweight transactional access. If you haven't worked with it before, ClickHouse is an open source columnar database that can scan billions of rows in milliseconds. Inside Delta Stream, ClickHouse can help power live dashboards, metrics, and materialized views, so you can explore data in motion without waiting for batch jobs or warehouse refreshes, or bolting on yet another complicated piece of infrastructure plumbing. And in the same spirit, if you're writing to Iceberg and S3, you don't need Trino, Athena, or Presto to query it. Delta Stream includes a Spark integration that lets you query Iceberg tables directly. Same SQL, same UI, no extra services or cluster management. So you get fast queries through ClickHouse, open storage through Iceberg, and unified control of all of it, including Flink through Delta Stream, with full separation of compute and storage. And because it's SQL-based, you can easily push back the results to Kafka, Databricks, Snowflake, whatever fits your data flow. And if you have any questions more on this architecture or how we do this, just in the interest of time, I'm not going to go through it right now, but please put those questions in the chat. I'd be happy to address them later. But all right, enough talking. I'm going to channel my inner Mark Zuckerberg and show how all of this works live. Hopefully I'll be more successful than he was recently. We'll start with some raw Kafka transactions and end with a live fraud detection dashboard, all powered by Delta Stream, ClickHouse, and Iceberg. So here's what we'll do. We're going to read a stream from Kafka, and actually it's Red Panda, but a Kafka API. We're going to write some daily rollups into Iceberg on S3. We're going to detect suspicious small to large transaction patterns using our ClickHouse-based materialized views for snappy access. And then we're going to visualize the results live in Grafana. Sound like a plan? Great. So give me a second while I go get this set up. Oops. In the meantime, I can play some hold music, or you can ask questions in the chat. Julie, has anybody asked anything so far?
No, not that I can see. I see one question. Somebody said compliance is our top concern. How does real-time streaming help with audits and regulators?
That's a great question. Because Delta Streams acts like a database, and we'll actually see this in a second, that it consolidates all of your streaming workloads, your Snowflake tables, your Iceberg tables, all into a single point of reference. So it makes it a lot easier to audit, create any type of RBAC style security. Just one single interface that acts, like a single source for all your streaming data. And we're going to look at that in just a second. So let me go ahead and start this.
Thank you for that. Yeah, I think that regulators care about transparency and traceability, and streaming gives you both, right? So with data lineage built into queries that update continuously, not once a day. So
all right, great. So this is the Delta Stream UI, and over on the left-hand side, we have the different places where you can start. Everything, and everything we're going to do is in real time here. So we have a workspace, we can see the queries that are running. But where I like to start is with resources, and we can add data stores. So you can see the different integrations that we have: Kafka for ingestion, an Iceberg store backed by S3. We have a REST store for people who are using Snowflake materialized views. Um, so this means all of our outputs, tables, roll-ups are all written directly into those open Iceberg tables. And if I wanted to add a new store, like for Kafka here, I would give it a name, and I would be able to just put my URI in. I would be able to add a schema registry, um, any type, the correct security that you might have set up, and then a username and password. And this will go ahead and add um, this data store. Once you have your data store configured, so I have a Kafka one here, I can open it up and see what type of data I have. So these are the topics that I have in this particular cluster, and I can view those topics. I'm going to start from the beginning so we get all the data that we have running, and it will actually print back what the topics are that we have. We can see them here or as JSON objects. And with these JSON objects, actually, you can copy them and you'd be able to inspect what the schema is of your topic. So, and for that, that's really important because uh, we want to make these topics queryable in uh, in Delta Stream. So the first thing that we need to do is take a look at those topics, which we can also see here. Here's that same transfer transactions. And as I mentioned, this particular topic has all of my transactions from a fake financial system. So if I want to create um, make this queryable, I will want to create a stream. So what this is doing is creating the metadata in Delta Stream that will map back to the topic that is sitting in Kafka. And I tell it the topic name, the value format, the timestamp. I can give it a lot of different hints there. So go ahead and run that. And now it will have created a new stream that I can see in my database section up at the top. So this is so once I've done that, I can treat that like I would a table in a database. I can say, select star from, I'm sorry about watching me type. And I'll have immediate access to that new topic that I created. So now I can do select star. I can do lots of interesting things. Like I can say, select, I can do user IDs and do a tumbling window. I can do counts and sums and averages. So I can definitely create my own any type of query that I want to. But what's interesting is, yeah, you can create a query, but you might also want to persist that someplace. And so I can say, all right, I'm going to make this in my Iceberg store. So I'm going to store it into Iceberg. This is the namespace and the table that I want to create. And it's just as simple as that. So any query then gets made with, can be made into any external table. So this is now going to be uh, making sure as new data arrives that this new table will automatically update. So there's no batch scheduler, there's no refresh job. And because it's on three on sorry on S3, we can actually query it directly the same way we queried that topic directly in Delta Stream. So I'm going to let that sit and hydrate for a while, and we can come back later and take a look. But that table is now available for me to use. Okay, so next thing we can do is we want to create some fraud logic. Actually, let's stop there for a second, and we're going to go look at the at my queries that I have running. So I do have this new query called demo daily rollup that I had built. It looks like it's running, and if I go look at it, it hasn't quite gotten some data running through it, but I'll be able to see the number of records. So from there, I can now look to see my different tables and topics that I have filling different parts of my application. So I already have a one already set up, kind of like cooking shows where I already have a set of tables running. But you can see that here's the different queries that are feeding those tables, and then here is my final result. So you're able to see everything that you're working on in a very visualized way from start to finish. All right, so let's do something a little bit more interesting. So let's add some fraud logic. So in this case, we're going to look for a pattern. So multiple small transactions from one user to another, followed by a large transactions. And this is where a ClickHouse-based materialized views shine. ClickHouse is, as I mentioned earlier, is a column-based database that's built for real-time analytics. It's extremely fast at scanning large volumes of event data. So when Delta Stream writes a ClickHouse powered materialized view, you can spot patterns like this in seconds instead of minutes or hours. Instead of waiting for a batch job to calculate aggregates, the results are continuously updated as new transactions arrive. That means that the dashboard reflects fraud in near real time, and analysts or downstream systems can react immediately. They can freeze accounts, flag the transfer, or trigger another workflow. So let's take a look at what that logic would look like. So very similarly, at the top of this, I'm going to say create materialized view. I'm going to say which topic that I want to use it from. So that transfer October that I had done earlier. And then I'm going to use something called a match recognize, which is a really powerful SQL feature in Flink that lets me do that fraud logic. So look for a small transaction and then a large transaction. And then I've also set to have a starting position equal earliest. And that way it allows me to backfill. So even though I might have data for, maybe a couple of days sitting in my Kafka topic, and I want to hydrate a materialized view back from then, I can tell it where the starting position is. And you can actually put any type of hints for Flink or Kafka in here that you want. So behind the scenes, Delta Stream is making these assumptions for you. It's using our years of experience running these things at scale to say, these are the right sizes, this is the right place to start. But if you already have the experience or you know how your data is going to work, you can override those at the same time. As I mentioned earlier, I actually already created this materialized view. So, it would have time to hydrate. And I can do I can just then run any type of query I want. And notice it comes back super fast. Like, and this snappy type of interface is very typical of ClickHouse. I'll run it again just to show you. Like, it's so fast. And it's keeping track of all the data that has been flowing into my system since this morning. And I'm using this actually to feed a Grafana dashboard. So I'll go ahead and refresh this, and it will, in this case, it's running a query that's saying, look at all the fraud events in the last 10 minutes, and then what are the fraud events in the last hour. And if you're familiar with Grafana, you can see here, like I mentioned earlier, that all of this data is all filled by queries. So I have gone from looking at a Kafka topic to creating a roll-up in Iceberg, and then a materialized view and a dashboard, all using SQL, and all in the matter of, what has it been, 11 minutes? Uh, and if we go back and take a look at the streams, we can see we've got this transfer transactions feeding two different queries. One, that materialized view that we just showed you that was on the Kafka topic, and this iceberg roll-up table. So I did go through that pretty fast. So I am happy at this point to open it up for questions and see if anybody was interested in learning a little bit more about the system.
Yeah, Rachel, I see that there are quite a few questions actually that
Oh,
popped
great.
up. And by the way, if anyone wants to ask question live, just raise your hand and I'll be happy to unmute you. But we have a few here. So let's answer live. How much do we need Flink expertise in order to utilize Delta Stream?
That's a great question. So you actually don't need any. You saw me create a pipeline behind the scenes. Each one of those queries uh, is actually its own Flink job, completely isolated and able to scale individually. I didn't know anything about Flink. To do that, I just wrote a query, and Delta Stream is using our years of knowledge on how to run those Flink queries to to make that happen behind the scenes.
Yeah, yeah. So here's another one. Saving money is our top priority. We see spiraling storage costs. How long does it typically take to see savings?
That's a great question. So, one of our customers is using Delta Stream for cost savings on Snowflake. So I see this pattern happening a lot where people take data from Kafka, and maybe the analytics team doesn't own the data in Kafka, so they were relying on an ops team to just dump Kafka data or CDC data from Postgres or another type of database into Snowflake, and they call that the raw data. And then from there, they're going to run ELT type of routines, maybe using dbt or Airflow, and it's going to take that raw data and it's going to create new tables. And I think Databricks likes calling this a medallion architecture. Go from raw to bronze to silver to gold. So every time that you run those queries to make changes, you are adding compute resources into Snowflake. You are adding storage costs into Snowflake. And if your gold tables do need to be updated in real time, so like if you're going to be using live tables, those get very expensive very, very quickly. So what Delta Stream does behind the scenes is it actually uses Snowpipe streaming to pipe the data directly into these tables. They'll be automatically updated, like we saw earlier, and you don't have to run a warehouse. So Snowpipe streaming actually avoids the whole warehouse side of it, so it's a lot less expensive. And then you don't have to use a live table, so you don't have to get that compute cost. I mean, our customer saw about 75% reduction in costs in Snowflake within the first couple of weeks. So it can be really extreme for use cases where you're trying to, what I think Confluent likes to call it, a shift left type of approach, where you're shifting your compute to before you insert this data into Snowflake or Databricks. Sorry, that was a very long answer, but did that make sense?
I think so. I think so. Um, s- how long does the typical integration take?
Um, so the thing that takes the most amount of time is making sure that Delta Stream has access to both the source and the targets that you want to set it up with. So as I mentioned, we have two different deployment modes. We have a SaaS deployment mode or serverless that we host it. For that, you would need to use private link or another type of or VPC peering to set up access to your source and sinks. If you're going to use BYOC, where Delta Stream runs completely in your infrastructure within your VPC, that will take a little bit longer because we will need to make sure that you have a VPC that's dedicated to Delta Stream available and that the permissions are set correctly. And then we'll help you terraform that VPC and then set up again the private link or connectivity to both your sources and targets. So how long does it take? A couple weeks, I would say, to in the most extreme case for BYOC. If you're going to be using SaaS, as long as it takes for you to do a private link setup.
Mhm, mhm. Here's a good question. How does your solution compare to others in the market like Confluence?
It's a great question. So um, so Confluent is doing hosted Flink, and they are because they own the Kafka market, right? So what they do know is that Kafka itself is not particularly you can't really join topics. Anytime you want to use that data for analytics or anything that's outside of just moving it from point A to point B, you're going to have to do stuff to it. So they've invested a lot of money into Flink and into a Flink solution. And that's great. I mean, if you just are looking for a hosted Flink, Confluent has an excellent solution for that. But Delta Stream wants to be your streaming platform. So we've integrated ClickHouse. We have Spark to be able to query your iceberg tables directly. We want to make the experience of using streaming akin to using batch. So you don't need to reskill all of your DBAs or your data engineers on how to use streaming technology. Instead, as you saw from the demo, it's a very comfortable, almost Snowflake-like interface where you're just writing queries and the stream processing kind of takes place in the background.
Yeah, well, thank you for that. So I have one more question here. I see multiple data stores on the left. This means you can combine data from multiple sources and push to one or more for storage.
You sure can. Uh, uh, so, uh, You can have multiple topics, so you can join one to many different Kafka topics. You can take data from a CDC topic and join it with a Kafka topic. You can use API calls if you want to enrich data through an API call. For that, you would use what we call a user-defined function. Once the metadata or once those streams and tables are created within Delta Stream, you can use them like you would any other table in any other database.
Mhm. Thank you. One more question here. How closely does your SE team work with ours? We find that identifying use cases is easy, but the reality of specifics tends to be more complex.
Devil's always in the details. I run the field engineering team, so that's my job is to work with you guys. And if you think getting a use case is easy, then you're more than 50% of the way there. We do actually find that use cases are sometimes the trickier ones to get to. The details that people usually stumble with is connectivity to the needed data sources. That's been my experience. But once you do that, then we are going to walk you through the completion of your project. So my team is dedicated to making sure that your system is production ready. So
Mhm.
we're going to work internally with our engineering staff and our infrastructure team to make sure that the types of jobs that you're running, that they're sized correctly, that that they're going to perform the way you want them to. So we have a pretty comprehensive pilot program that makes sure that we're doing the right testing, the right integration tests. Also, something that I didn't mention earlier is that everything that you saw on that screen through our UI is available through an API. So this can all be integrated through your CI/CD frameworks. And that's something else that my team will help you with is, getting the implementation or getting the queries written is one thing, but making sure that it works uh, th throughout your CI/CD platform is also really important.
Thank you for that. So I don't see any more questions, maybe a last call for questions, but I'm definitely very grateful to this audience for being so very active. And I want to mention that if anyone has more questions, please feel free to connect either to Rachel or myself via LinkedIn, or you can also email us at hello@deltastream.io. It's very easy to remember. And you will also get a thank you note via email with contact information in case you have some more questions that you did not ask. And I truly hope that you're walking away with a few new ideas you can put into practice. And in FinTech, it's pretty simple. The faster you move your data, the faster you move your business. That's what gives you the edge. So, and I also want to say that this is really just the start of the series. We're going to have them monthly. The next one is going to be in November. So please stay tuned. And so again, thank you so much for spending part of your morning with us. Very grateful. And thank you so much, Rachel, for this very informative demo.
Yep. Thank you, Julia. And thanks y'all for coming today.
And with that, we're going to wave goodbye.